with right triangles. So let's review what is a right triangle. So what is a right triangle? A triangle with a right angle. Good. How much is a right angle?
90 degrees.
90 degrees. Good. So a triangle with how many 90-degree angles? One. Good.
And how do you tell it's a right angle? What do we use to unbox a box?
Right triangle. Triangle with one 90-degree angle, and we'll show that. All right, so let's draw a right triangle over on the side here. We'll just draw a classic, what we think of when we think of a right triangle. So at 90 degrees, remember, makes kind of that capital L shape. Now, even though Miss Morell is an amazing drawer, did so good, and now it's probably almost 90 degrees. To show my reader that it's exactly 90 degrees, what am I going to do? Good, put that little box there. All right, now we have two classifications for those sides of those triangles. One classification, oh, thank you, is your leg. And legs are the sides that create the 90-degree angle. Legs are the sides that create that 90-degree angle. So I'm going to do legs with pink today. All right, as I look at my legs, it's what they come down to that 90-degree angles. They kind of surround that 90 degrees. So I have that leg and a leg. There's two of them. So go ahead and make sure you get that labeled even if you're not using colors. Label your legs. Those are really important. They're the sides that create the 90-degree angle. All right, now our other side is called the hypotenuse. Hypotenuse. Let's all try saying that on the count of three. We're going to say hypotenuse. 1, 2, 3.
Hypotenuse.
Good. So we have like a third of us. Yarman, off your phone. We need the rest of us. Hypotenuse on the count of 3. 1, 2, 3.
Hypotenuse.
Yay! So much fun. That was like almost half. So exciting. Hypotenuse is a crazy word. It's spelled Hypotenuse. Hypotenuse. What are you doing? All right, hypotenuse. Don't you dare throw that. You gonna erase it and put it back? All right, hypotenuse is the side across from the 90-degree angle. The side across from the 90-degree angle.
So if you see the box, you just have to look across it. That's the hypotenuse.
What's our other word we use for across sometimes? Opposite. So if you want to use that word, you could put that underneath opposite of across. I'm going to use green for hypotenuse today. So if you pick two colors, pick one for legs, one for hypotenuse. and just like Mr. Kwan said, we look across from that 90-degree angle, and we find that hypotenuse. Now, hypotenuse is a silly word, I think. It's a Latin word because triangles, remember we talked about this back in chapter 4, if you were with us chapter 4, triangles are very Greek. Okay, the Grecians loved the triangles because they were obsessed with perfection. So anytime they did art, anytime they did any thinking, they wanted to think and do art at the highest level, the most perfect they could do. So to them, triangles were the most perfect shape because they could make it make sense in every way. They could break down every shape into those triangles. Okay? So, you guys ready for the drama of Pythagorean theorem? Okay, let's spell that out first. Pythagorean theorem. Pythagorean.
This is where Miss Morel becomes a history teacher for like a few minutes.
For like a solid 45 seconds. Tishan. What do you mean, dang? You're not even trying to be smooth. Alright, Pythagorean theorem. Now, Pythagoras is a philosopher. Now, nowadays, philosophers really just think about thinking, and they think about how to think and how things are created based on how other people thought, and they break it all down about thinking. Back in the Grecian times, philosophers did a lot of things. They may have looked at astronomy, they might have looked at math, they looked at science, they did a lot of thinking about a lot of things. And then you'd find a philosopher, if you wanted to be a philosopher, you'd find one of the big philosophers to shadow, like so Socrates, Aristotle, Pythagoras. That's this guy's name, Pythagoras. Okay? Do you guys want to know the drama about Pythagorean theorem? Yeah. Pythagoras wasn't actually the person that found the Pythagorean theorem. It was one of his followers. One of the people that followed him around was like, hey, Pythagoras, look at what I found. And Pythagoras was like, dang, that's cool. Look, I found it. And the follower was like, no, I just showed you that I found it. And Pythagoras was like, yeah, I found it. I did it. So Pythagoras took all the credit for the Pythagorean theorem, even though he's not really the one that discovered it. Interesting, right? It's the T. All right, so Pythagorean theorem says for any right triangle, it's kind of like when, like songwriters or like singers are like, this is my song. And then somebody eventually is like, no, you demoed my song. Like you stole the part of my song. You know what I'm saying? No? Cool. All right. For any right triangle, a squared plus b squared equals c squared. Can you just try to pay attention and then maybe you'll not have to worry so much about finishing things on time. All right, a squared plus b squared equals c squared. What is our a and our b? All right, I don't know why I asked that. That was a silly question. A and b are the legs of our triangle. So whatever color you picked for legs, use that same color there. Okay, it has to be A is a leg. B is a leg. Amin, off your phone. And C is the hypotenuse. So the legs don't really matter which one is which. What really matters is our hypotenuse has to be C. Has to. How are we feeling? Decent so far? Alright, we just have 2 examples with this. You guys are crushing this. Alright, let's start with example number 1. We're going to draw a picture of a right triangle. I'm going to go to the left with my right angle there. And to mark my right angle, I'm going to use that 90 degrees. That little boxy thing. I'm sure it has a specific name in the math world, but I don't know what it is. I should learn it. Little box. Alright, on this side we have 8K KM. What does KM stand for? Good. Kilometers, kilometers. Kind of like a mile, but the English version. Just kidding. The whole world uses it, but us. All right, and then this one's going to be 15 km. And our goal is to find x. And here's x. Literally, you don't need your phone right now. You can go a second without it. All right, so is this a right triangle? Yes, so as soon as we know it's a right triangle, we can instantly go into our a squared plus b squared equals c squared. The one that is the most important to make sure that we get the right number for it, is it a, b, or c? C, because that's what it's equal to. So it's really important that c gets the right number. C is our hypotenuse.
So which one is the hypotenuse in this triangle? X. How do you know?
Side we don't have.
The only side we don't have, and it's right across.
Okay, so across from that 90, so our hypotenuse is x. Good. All right, which means what is our a and our b? Good. 8 and 15. What do we call those other sides that's not the hypotenuse? Legs. Good. It doesn't matter which one goes where. Do we want 8 first or 15? Okay, you guys are crazy. 8 squared plus, what's b? 15 squared. Now we have to solve for x. That's our goal, is to get x by itself. But before we get x by itself, we want things to be simplified. We want to make it easy for us. So as I take a look at this, is there anything that I can simplify that I know the answer to?
Square root.
Is there anything I know the answer to?
8 squared.
Good. 8 squared. What is 8 squared? What is that telling us to do?
8 times 8.
Good. 8 times 8, which is 64. And then we can do 15 squared, which remember is just 15 times 15, which is 225, equals x squared. Okay, again, we want to combine those terms. So 64 plus 225, we want to simplify those. We get 289. So now that it's simplified on one side, is that what x is equal to? No, that's what x squared is equal to. My goal is to find just x. Good. How do I undo a squared? Square root. Good. You already answered it. I asked the question anyways. All right, so x equals. Now remember on your phone, if you're going to use your phone, you need to make sure that if you're going to use it on your phone, if you're going to use your phone. Oh my gosh, my words, Miss Morel. You're going to make sure that your auto lock is off. You're going to make sure that you have your screen unlocked, and you're going to tip your calculator sideways. Notice how my calculator is not unlocked, so it's not tipping. So I need to do my Face ID didn't work. Okay, so now it's unlocked. Go there, tip it sideways. There we go. And it's this button right here, the square root.
This is why we always recommend decimals, so that you don't have to go through all this step just to do this calculator.
As well as,
Go ahead, whichever one works best.
but which one do you get to use on your test? Desmos. Alright, so 17 equals x. Whoops, shouldn't have boxed that. 17 what? Kilometers. Good. Kilometers, kilometers, all the same.
And in period 1, we have a lot of students forget to do this step where you have to square the numbers. So when you're doing your quick calculator, remember to check which number has a square and which one you have to do it. Because if you don't do it, you can't really find the answer. You can, but it's a bit complicated.
But on practice, we're going to have you show your work, so taking your time to do that. Alright, last one, number 2. Number 2, we're going to do our what do you call these? Right angles, right triangles. I was going to call it a rectangle. Yikes. We're going to make that right angle kind of at the top, actually. So That one's a little harder for me to draw. As I look at it, it doesn't really look like a right angle. Stop. What grade are we in? Stop throwing things. Yes. Do your notes. Seriously. You need a pencil. Put it in your writing hand. Drop what you have in your writing hand. That's not your pencil. Put that eraser down. Put the eraser down that's in your hand. Okay, now write. We're on number 2. Draw this picture. You have to look at the screen. Okay, so my right angle is up at the top here. All right, this time I have 7.9 centimeters here. .7 centimeters here. And x here. And again, our goal is to find x. Do you have this written? You don't have that. I just saw you draw, and you don't have that drawn in. Stop looking at me. It's weird. All right, so we look at our formula. A squared plus b squared equals c squared. Our most important is the c. So where is our c located? Which one is our hypotenuse this time?
16.7.
Good. The 16.7 is our hypotenuse. Our other numbers, doesn't matter which order we go in. We have 7.9 and x. Do we want 7.9 first, or do we want x first? Okay. So x squared plus 7.9 squared. All right, before I solve, my goal is to first simplify, get answers that I know the answers to. Yeah, in that box right. Nope, right, nope. Right by your hand. Put your hand up. Up. That way. There you go. Alright, so as I do this, I'm looking at Desmos. I'm going to do 7.9 squared. So 7.9 times 7.9, or we can use this squared button here. Okay, even though it's 2 decimals, we're going to leave that as it is right now because it's not that inconvenient. So x squared plus 62 and 41/100 equals, and again we want to evaluate this side. We're going to make things as simple as possible first. So 16.7 squared. We can do 16.7, you can use that squared button, or you can say times 16.7. You keep looking at me, so I keep looking at you. It's weird. We get 278.89. Again, even though it's a decimal, we don't need to round it yet. That's fine. But our goal is to get x by itself. So what's on the same side as that x?
Plus 62.41.
Good, we have a 62 and 41/100. What else do we have on the same side as x? A squared. So we need to decide, we have to do inverse operations. We have to go from least important to most important. What's the most important to this x?
Squared.
Yeah, it's squared. They're hanging out. So we're going to get rid of that 62 and 41/100 first, because adding, if you think of GERMDOS or your order of operations PEMDAS, adding is at the very bottom of that list. So how do we undo adding?
Minus.
Good, subtracting. So we're going to subtract 62 and 41/100. We do it to one side. All right, use my calculator here. 278.89 minus 62.41. 0.41. We get 216 and 48 hundredths. Again, no reason to round. Just 2 decimal places. Yes, it's a pain, but we can do it. All right, am I done? Nope, what's our last step?
Squared.
Yeah, it's a squared. How do I undo a squared?
Square root.
Square root. And if I square root one side?
Shift the other.
Good. So x equals, I'm just skipping a line because it felt really crowded to me. I'm going to take that square root button on Desmos. It's just this one right here. And then I can hit that A and S button for answer. All right, now this one's an irrational number. It's going to go on forever and ever and ever, and it never ends and it never repeats. So we're going to round it to the nearest hundredth. Hundredth is how many decimal points? Decimal places. 2, good, because it goes tenths, hundredths, and then thousandths. So I have 14, and am I going to keep it at 71, or would I want to change it to 72?
Keep it at 71.
What number tells me to keep it?
3.
Good, the 3 tells me to keep it. So 14 and 71 hundredths centimeters. Nice. All right, I should have done this in pink. Sorry, forgot. I'll go back and do that. Make that nice. All right, we still have 3 minutes before lunch. So in the time frame before lunch, you